Welcome to a lesson with Dr. Powell. Let's compare the different ways that we have of computing a volume of a solid formed by rotating a region around an axis. We have axial growth or radial growth. For axial growth, what we do is at each axial position, we think right at the position we cut in the region by a straight line. And then the derivative of the growth is simply the area produced by rotating the straight line itself around the axis, and it produces a washer. Now, for radial growth, we're going outward this way. At each radial position, we have at this one radius, it cuts through the region by a horizontal line. And to find the derivative with respect to radial growth going up this way, we simply rotate that horizontal line around and it produces a shell. So basically what we could think of just drawing lots of horizontal lines and then basically integrate the area produced by each horizontal line as we cycle through the horizontal or go through the horizontal lines. So with respect to y, as y goes from 1 to 2. Or we can think about drawing or kind of putting vertical lines through this, rotating each one of those vertical lines, and getting a washer. And that would be with respect to x as we go from 1 to 2. So we have our two different options. So let's take a look at this one, the washer option. So at a particular value of x, what's happening? We have a washer with an inner radius, it looks like of 1, and this radius actually looks like it's 1 plus simply it looks like it's from here, it's just the x value because y is equal to, let's see, yeah. Okay, y is equal to x. So we go all the way from here up to the curve. So it's just x. So it looks like the larger circle is pi x squared, and the smaller circle is just pi times 1 squared. And then we're just taking that was just an arbitrary x position. We just integrate this. Then this is what we integrate from 1 to 2. Now for this guy right here, let's see what happens. So this time we're going to take horizontal lines. So let's just take a horizontal line at a particular position y and see what happens as we rotate it around. We get a cylindrical shell. What's the radius at this place? Well, with respect to y, at this y value, the radius is simply, well, it's this distance, which from y is equal to x at the particular y value is just y. So we need to write it in terms of y. So the radius is y. So it looks like it's 2 pi y is the circumference. The height is just this length here. And that length there is just the difference between 2 and this y, the y value, or the 2 and the x value. But you write this x value in terms of y, which is y is equal to x. So it's just 2 minus y. So we get the height is 2 minus y. And then with respect to y, and y in this case is also going from 1 to 2. So we could compute the volume in these two different ways. Thanks for watching.